Okay, now this figure is a lot different. This is a regular octagon. Now you can do the same kind of deal with any kind of regular polygon, but we decided to do an octagon. You don't have to actually draw the whole entire octagon out if you don't want to. What I would do is you could just draw one of these bases and one of these sides right here. It doesn't even have to be to scale, so you know it's going to be some kind of an obtuse angle. But you could just draw this part right here and understand that this would be the center of that octagon. And maybe even draw this side right here. That's perfectly fine. So what we're going to do is, first of all, we need a formula for an area of a regular polygon, and that is area equals 1/2 the perimeter times the apothem. Now look what they gave you. They were nice about it, and they gave you the perimeter. It's 80 inches. So really, all I got to do is 1/2 times 80 times, we'll leave that blank because we don't know what that is, and that's the apothem. So how in the world do we find the apothem? That's the real work. Well, what is the apothem anyway? It's from the center of this polygon, this regular polygon, and it's perpendicular to any of those sides. I'm just going to drop it straight down. It's a little easier to see if it's just straight down, I think. So that right there is the apothem, and I'll call it A for apothem. So you think, okay, how in the world am I going to solve for that? I got nothing. I know the perimeter. Okay, so if I know the perimeter, what else do I know? I know there's 8 sides, and if they all add up to 80, I know each side, which is 10. So from here to here is 10. Right? And we talked about this being perpendicular. We've talked before about what's going on here. If this is perpendicular, that splits this side into 2 equal places. So this, let's just do it right here, doesn't really matter. So from here to here would be 5, and from here to here would be 5 as well. Now what else are we going to do? In order to find this thing right here, I'm going to have to draw another line, and that line is from the center to where these two things come together, these two sides come together. Okay, we'll call it the vertex. And in fact, I'm going to draw 2 of them just to show you something. Alright, now I could have drawn to every one of these. Now how many angles would I have? Watch, I'll do a few of these. If I go from here to here to here, and I just kept on going around, how many of these angles would I have? Well, I'd have 8 of them. There's 1, 2, 3, then that would be 4, 5, 6, 7, and then 8. So what I can find, just knowing how many sides I have, what I can actually find is this angle right there. How do I find that angle? I take 360, because that's all the degrees all together, and divide it by how many angles I have. And so 360 divided by 8 is, I got that somewhere, it's 45 degrees. Right? So this big angle right here is 45 degrees. That would be the same with all of these angles. I'm only interested, though, I want to find the apothem. I want to find this up and down right here. So I'm just going to look at this right triangle. I'm only interested in this angle from here to here. Well, it's going to be half of the 45. So this angle right here is 22.5, and that's half of 45. I could use this angle, or I could come down here and use this angle as well. I take that away from 90, and I get 67.5. Sorry, this is a little ugly. I should have put the 5 down in here. So that's 67.5. So I've got a right triangle. I know one side. I'm trying to find the other side, and I know an angle. So I can use trig functions, and I can do what I need to do to solve for A. So now I'm ready to solve for A. You could have used this angle if you wanted to, but for some reason a lot of people are comfortable using this bottom angle. If it all depends on your preference. Okay, let's just do this. Let's use this angle down here, 67.5. So what do I have? I've got opposite, and what I got this one right here, which is adjacent. Opposite and adjacent. Which trig function is that? Well, that's the tangent. So the tangent of 67.5 is equal to the opposite, which is A, over the adjacent, which is 5. Solve for A, multiply both sides by 5, throw that into your calculator, and you get 12.1. So that's your apothem. So what do you do with that apothem? That's not your answer. I probably shouldn't have circled it, but what do? You put it right up here, 12.1, chuck all that into your calculator, and you should get somewhere around 484. And that's in inches, so it's in inches squared. And that's the area of the whole entire thing. 1/2 the perimeter times the apothem. All the work was finding the apothem. Go through it again. The key part, I think, is to find that angle. How'd you find that angle? 360 divided by 8. Take half of it, because you just want to find this little bit right here, which is 22.5. You could just use this if you wanted to. You could have said opposite over adjacent here, and you could have gone tangent of 22.5 equals opposite 5 over adjacent. But then your math would be a little bit more difficult. It's a equals 5 divided by the tangent of 22.5. Try it. Try either one of them and you'll still get the same thing. You'll still get 12.1. However you want to do that. Hope I didn't confuse you anymore. Let's finish this up. We got one more to do. Alright, this is the last problem on this quiz. Last problem of the review. Thank goodness. I'm as tired of doing this as you are, I'm sure. Alright, here we go. Number 10, it says a pie has a diameter of 9 inches. So it has a diameter of 9. Don't put the 9 right here. The diameter is 9. What is this? That's the radius. So let's just put 4.5 for the radius. Each slice of pie has a central angle of 45 degrees. So I've drawn that in here already. So that's 45 degrees. What's the area of each slice of pie? So what we're trying to do is trying to find the area of just this sector, is what we call it. Oops, right over the 45, but I think you get the idea. Alright, so where do we go from here? Let me change my color back again. Okay, this is 45 degrees. Right there. Okay, that's a little bit better. So what's the area? What do we have to do? Remember, area of the whole entire pie is going to be just pi r squared. No pun intended right here. But what are we doing? We're just finding a sector, a part of the whole circle, portion of the whole entire circle. How much of the whole circle are we finding? We're only finding 45 degrees out of the whole circle, out of 360. You've done this on several occasions. And now you just go pi r squared. This is very similar to one we did earlier. Pi r squared. And the r was 4.5. Make sure you don't put the 9 in for the r because it's half of the diameter. And now, oh, I forgot to square it. 4.5 squared. And now you just chuck that in your calculator. 45 divided by 360 times the pi button times 4.5 squared. Make sure you put that all in correctly, and you'll get a final area of approximately 8.0. It goes off to other decimals. It's not exactly 8, but it goes to 8.0. And that's area, so it's inches squared, and we're done.